we will continue our discussion on principle of hydraulic machines and system design. We will discuss in this lecture about hydraulic turbine and its classification. So, today I will briefly discuss about what is hydraulic turbine and how we can classify hydraulic turbine in different categories. So, as I said, rather I have discussed very beginning of this course that we can classify turbo machines into different categories. So, hydraulic turbine is also a prime mover in which it is hydraulic turbine and pumps differ because of the change of direction of energy conversion. In one case mechanical energy is converted to increase the stored energy of the fluid either in terms of velocity, pressure, something of velocity head or pressure head anyway, or while in case of a hydraulic turbine reverse is true, that is we are utilizing the stored energy of the fluid to increase rather to convert it into the mechanical energy. So, as if we are increasing the potential energy of the fluid and we are utilizing rather we are changing that potential energy in a different other form, so that the rotating component or the rotor of a turbine is rotating and which is connected with some alternator or generator and we are getting electricity. So, we will discuss now in detail about how we can classify it based on the different features of the hydraulic turbine, and then we will slowly proceed to discuss about the details about each of the hydraulic turbines, I mean which the categories what I will discuss today. So, that I have discussed that hydraulic turbine. So, it is a since turbine may be hydraulic turbine, steam turbine, gas turbine, but today I mean in this course since it is only hydraulic machine, so we will be focusing our discussion only to the hydraulic turbine. So, hydraulic turbine so is a prime mover. So, hydraulic turbine is a prime mover and which transform potential energy which is stored in terms of in a reservoir. So, intermolecular energy, the potential energy of the fluid is getting transformed into the mechanical energy of a generator. So, this is very important that how we can transform mechanical energy into the so, hydraulic turbine is a prime mover in which we are converting the potential energy of the fluid into its different form rather in the mechanical energy, and we are utilizing that energy to run or to drive a rotor, and in a shaft of that hydraulic rotor turbine rotor one generator is connected and from which we are getting electricity. So, I will write in briefly that a hydraulic turbine is a prime mover in which potential energy of the fluid stored, the energy remaining stored in the fluid, right, I mean rather stored in a reservoir. So, a hydraulic turbine is a prime mover in which potential energy of the fluid stored in a reservoir is transformed into the mechanical energy, to drive in mechanical energy of rotation, rather to kinetic energy, mechanical energy of rotation to drive an electric alternators or generator, to drive an electric alternator or generator. So, this is very important. So, a hydraulic turbine is a prime mover in which potential energy which is stored in the reservoir is transformed into the mechanical energy of rotation, rather kinetic energy to drive the generator or alternator. So, we are getting electricity. Now, the turbine runner and the rotor of the generator, so this is very important. So, as I said very beginning that whatever it is, I mean hub plus blades. So, whenever you are talking about hydraulic machines, you are having hub and there are blades. So, hub plus blades, which is known as impeller for a pump, the same thing is known as runner for a hydraulic turbine, and we call it rotor for compressor. So, the runner of hydraulic turbine, or sometimes we call it rotor, the turbine runner and rotor of the electric alternator. So, the turbine runner and the rotor of the electric generator are connected or are mounted on a common shaft, mounted on a common shaft or the same shaft, that is, an entire assembly is known as turbo generator. So, the turbine runner, the shaft of the turbine, so turbine runner is mounted on a shaft, on the same shaft we are also having this shaft electric alternator. So, they are having common shaft and the entire assembly, and that is why entire assembly is known as, sometimes known as, rather I mean we are rather frequently referred to the we call it turbo generator. So, this is very important, right. So, the turbine runner and the rotor of electric alternator are mounted on a common shaft, and that is why entire assembly is known as turbo generator. So, what I am telling, a hydraulic turbine is a prime mover in which potential energy which is stored in the reservoir is transformed into the mechanical energy of rotation to drive an electric alternator or motor, and the turbine runner and rotor of the turbine runner as well as the rotor of the electric motors are mounted on a common shaft, and entire assembly is known as turbo generator. So, what is, I mean how energy is getting converted. So, in a hydraulic turbine only we are having transform of potential energy into the mechanical energy of rotation or the kinetic energy. So, hydroelectric power plants, normally hydraulic turbines are used in hydel power plants. So, I am writing that hydroelectric power plants utilize, so we are utilizing the potential energy of the water which is stored in the reservoir. So, we need to have sufficient head to rotate the runner of the hydraulic turbine, and since the runner of the hydraulic turbine is mounted on a shaft, on the same shaft we are having the rotor of electric motor. So, electric motor will, or alternator will run and we will get electricity. So, hydroelectric power plant utilizes the energy of water falling through a height or head which varies from a few meters to handle few meters, let us say of 1000 meter to 500 meter to 1000 meters to 1000 meter, right. So, hydroelectric power plants utilizes the energy of water falling through a head which varies from a few meters, 500 meter to 100 meters, and to handle such a wide range, rather wide range of heads, various turbines are employed. So, now to handle such a wide range of head, So, hydroelectric power plant utilizes the energy of water falling through a head which varies from a few meters 500 meter to 100 meter, and to handle such a wide range of head, hydraulic turbine, rather various turbines are employed, various turbines are used. So, various or different hydraulic turbines are used. Different hydraulic turbines are used. So, since we are utilizing a range of heads only to, because we until unless we are having sufficient head, we won't get sufficient amount of potential energy, and if we do not have sufficient amount of potential energy, we won't get sufficient energy of mechanical energy of rotation. That is, the electricity that will be generated, that will be produced, will be very less. So, we need to utilize sufficient amount of head, and now to handle such a wide range of head, wide range of heads rather, we sometimes use different types of hydraulic turbines. So, different hydraulic turbines are employed or used. So, hydraulic turbines based on that, and that is why this hydraulic turbine are classified accordingly. Hydraulic turbines are classified into different categories, right, and that is what is today's discussion. So, now we have systematically discussed that, we have seen, rather I have discussed at the beginning of this course, that depending upon the direction of energy conversion, we can classify turbo machines into two different categories. One is pump, where we are having conversion of mechanical energy into the mechanical energy is converted to increase the stored energy of the fluid in terms of pressure or velocity, whatever it is, while in case of hydraulic turbine we have seen a reverse scenario, that is the potential energy of the water which is stored in a reservoir, which may be situated a long distance apart from the axis of the turbine, and that is allowed to fall freely through pipelines, not freely through pipelines. We will discuss in detail how it can be conveyed from that reservoir to and can be connected to the inlet of the turbine. So, that water can be allowed, the water can be allowed to fall from that height, and it will impinge, rather it will strike the turbine runner, and the turbine runner will start rotating. Since turbine runner as well as the electric motor or alternator are mounted on the common shaft, so the moment at which turbine runner start rotating, the electric generator will start rotating and will get electricity. Since we are utilizing a range of heads and it varies a few meters, let us say from 500 meters to 500 meters to 1000 meters, because if we do not have sufficient amount of head, we won't get sufficient amount of potential energy, and which will eventually culminate in to a relatively less amount of electricity. So, to handle such a wide range of head, different hydraulic turbines are used, and accordingly hydraulic turbines are classified into different categories. So, now I will discuss about that how we can classify hydraulic turbine. So, hydraulic turbines sometimes is known as hydro turbines. So, hydraulic turbines, sometimes they are known as hydro turbines, like steam turbine, gas turbine, and hydro turbines. So, working fluid is the water. So, the hydraulic turbine can be classified broadly into two categories, as I said that to take into account a wide range of head. So, broadly into two categories. One category is known as impulse turbine, rather impulse hydro turbine, impulse hydraulic turbine, right. Example we will have to give. So, one example is Pelton wheel. So, Pelton wheel is an example of impulse hydraulic turbine, or another one is called reaction turbine. So, these are two broad classifications based on the head being utilized are in these two turbines. So, based on the head being utilized to generate electricity, these hydro turbines are classified into two broad categories. One is impulse hydraulic turbine, that is built on wheel, and one is reaction turbine. Reaction turbine further can be classified into two categories, one is known as radial, another is axial. So, reaction turbine further classified into two subcategories, one is radial flow reaction turbine, example is Francis turbine, example is Francis turbine. Another category is known as axial flow turbine, axial flow turbine, example is Kaplan turbine. These are the name of the scientist and or engineer, and to honor the name of them the turbines are named like this, Francis turbine and Kaplan turbine. So, axial flow turbine, Kaplan turbine, propeller turbine. So, propeller turbine like this. So, axial flow turbine further classified into two categories, one is fixed blade, another is adjustable blade, that is blades are adjustable. Adjustable blade example is Kaplan turbine, and fixed blade example is propeller turbine. So, this is what is the classification of hydraulic turbine, that whatever we have discussed, that hydraulic turbines are the prime mover in which potential energy of what fluid is converted to the mechanical energy of rotation, that is kinetic energy. So, essentially we are having we need to have a reservoir which will be situated sufficiently long distance at a certain height from the axis of the impeller, axis of the runner, and then water is allowed to fall from the reservoir and that will strike to the runner through certain arrangement system, and while it is impinging, so that time fluid will gain some amount of, so maybe the stored energy which is remaining in the reservoir, that will slowly convert it to the kinetic energy, and that whenever it is striking the runner of the turbine, that kinetic energy is trying to rotate the runner and we will get some rotational speed of the runner. Since the electric motor or alternator is mounted on the common shaft, so that will rotate and we will get electricity. And since we need to utilize sufficient amount of head, and based on the head being utilized in a turbine, this can be classified into two broad categories, of course not broad depending upon the head. Their working principle are also different, that we will discuss. So, impulse hydraulic turbine and reaction turbine. Impulse turbine example is Pelton wheel, reaction turbine can be further classified as radial flow and axial flow. Radial flow is example is Francis turbine, and axial flow again this is adjustable blade and fixed blade. Adjustable blade is a Kaplan turbine and fixed blade is the propeller turbine. Now, we will slowly discuss about what is impulse turbine and what is reaction turbine, why we call it impulse turbine and why it is reaction turbine, it is very important. So, impulse turbine is a class of hydraulic turbine which will have a fixed nozzle, one or two fixed nozzle, and in each of which the fluid pressure is converted to the kinetic energy of an unconfined jet. So, whenever water is allowed to fall from reservoir, that will initially enter to the nozzle. So, the function of nozzle is to increase the velocity head and pressure. So, amount of height that we had, so we are having pressure, that pressure is converted to the velocity head, and one or two nozzles are there, and whenever fluid is flowing through the nozzle, that fluid pressure is converted to the kinetic energy of unconfined jet, which then impinges or strikes the blades of the hydraulic turbine buckets and wheels of the turbine, and then it start rotating. So, impulse turbine, what is impulse turbine? Impulse turbine, very important. So, in impulse turbine I am writing again, in impulse turbine there is one or more fixed nozzles, there are one or more than one fixed nozzles, and in each of which fluid pressure is converted to the kinetic energy of an unconfined jets, which then, so jet or jets which then strikes or impinges, the sometimes on a bucket or blade of the vanes of the wheels of the turbine. So, impinges the bucket, sometimes they are known as bucket or vanes placed around the circumference of the wheel of the turbine, placed on the wheel of the turbine. Fine. So, in impulse turbine there will be a nozzle, either there will be one nozzle or two nozzles through which water is allowed to pass through through which water is allowed to pass. While water is passing through the nozzle, pressure head is converted to the velocity head, and then velocity head of unconfined jets, and then that jet strikes the or impinges the bucket or sometimes known as vanes of the wheels of the turbine, and while it is impinging, it is creating a thrust and that will start rotating, right. And there is practically no change in pressure of the fluid, there is as it flows through the runner of the impulse turbine. So, this is very important, and this is the fundamental difference between impulse and reaction turbine. So, I am writing that whenever fluid is flowing through the runner of the turbine, so there is practically no change in pressure when fluid is flowing through the runner of the turbine. So, whenever fluid is flowing through the runner of the turbine, there will be no change in pressure practically. So, only all the pressure head is converted to the velocity head, whether it is equivalent to the velocity head, that is very difficult to say, but most of the pressure head is converted to the velocity head while it is flowing through the nozzle, and then in the form of an unconfined jet, and then the jet strikes the bucket and or the vanes placed on the wheels of the turbine and it starts rotating because of the thrust. We will discuss about how it is creating a thrust and how when it is impinging the buckets, then how it is rotating, and that is from there we will try to calculate the efficiency of the impulse turbine. And there is practically no change in pressure when fluid is flowing through the runner of the turbine, but this is the difference. But we will see that in case of a reaction turbine, pressure gradually changes as it as the water flows through the runner, and in fact all the pressure head is not getting converted to the equivalent amount of velocity head while liquid is or fluid is flowing through the runner, and that is why you need to have another kind of a special device known as draft tube, which is connected at the trail of the hydraulic turbine. That we will discuss while we will be discussing about the reaction turbine. So, this is about the impulse turbine. Now, the reaction turbine on the other hand is something their operation is something different than the impulse turbine. So, in a reaction turbine, the change from pressure to kinetic energy. So, in a reaction turbine, pressure changes. In a reaction turbine, pressure changes to the kinetic energy, So, in a reaction turbine, pressure changes to the kinetic energy gradually. Pressure head of water, rather pressure head of fluid changes to kinetic energy gradually as the fluid passes through the runner gradually, right. So, in a reaction turbine we have seen that in impulse turbine there is practically no change in pressure as the fluid is flowing through the runner of the turbine, but in a reaction turbine normally pressure head of the fluid is converted to the kinetic head, not equivalently, but mostly pressure head is converted to the kinetic head as the fluid passes through the runner gradually. And for this gradual change of pressure to be possible, and for the runner must be that is very important, gradually, and for this gradual change of pressure, rather for this gradual change of pressure entire runner is remaining enclosed. In a reaction turbine, pressure head of fluid changes to the kinetic energy as the fluid passes through the runner gradually, and for this gradual change of pressure entire runner is remaining enclosed and runner is completely enclosed, that is not open to ambience, completely enclosed, and the passage in it completely full of working fluid. Completely runner must be completely enclosed and the passage in it and the gradual change of pressure entire runner is completely enclosed, and the passage in it remains completely full of working fluid. So, this is very important. So, this is a fundamental difference, that in a reaction turbine entire runner is remaining enclosed, not only that entire passage of fluid, entire passage remaining full, rather filled with working fluid, and gradually takes place, the energy conversion takes place gradually, while in case of impulse turbine there is practically no change in pressure as the water flowing through the runner of the turbine, while most of the energy conversion takes place when liquid is flowing through the nozzle, that is all the pressure head is converted to the velocity head. So, this is all about the two types of turbine, impulse turbine and reaction turbine, and we have classified. We will discuss slowly the working mechanism, how we can convert the mechanical pressure head to the velocity head in impulse turbine, and we will work out we will exercise the mathematical form of the how we can convert that head to the mechanical energy or kinetic energy. We will try to calculate efficiency, and also we will do the same for the reaction turbine. So, with this I stop here today and we will continue this discussion in the next class. Thank you.